Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This is part 2 of my Polymorphism mini-series. I'm going to open up my web browser to my website javacjava.com, select Menu, and Java OOP Tutorials. I'm going to scroll down here to the Polymorphism Part 2. I highly recommend watching my introduction to Polymorphism and my Polymorphism Part 1 tutorials before continuing. Now, the topics for this tutorial are: the object type that a reference variable is declared as will directly affect which methods it may invoke. We can use a technique called casting to invoke methods from subclasses that are not known to the reference variable superclass type. An interface can be the type for a reference variable. The instanceof operator can be used to determine if an object is a subtype of another class or interface. And here's a quick refresher. Now, a reference variable may be assigned to an object of that specific type, or any object that is a subtype of the declared type. Okay, let's come down here. Let's go ahead and click down on our left mouse button, and I'm just going to use the down arrow on the keyboard to control this here. We've got a lot to do that. Control C to copy, all right, or right click and select copy. I'm going to move the browser off screen here. I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really quick by right-clicking, selecting New, Shortcut, type in CMD, Next, and Finish. It's just that easy. Let's open that thing up here, type in Java C. Java C is the compiler. Press Enter on that. You should see all this stuff scroll by. If you get an error message watching my tutorial on installing the Java Development Kit, I want to make sure you get that installed and configured properly before continuing. CD space / CD is short for change directory, and / tells it to go to the root. I'm going to make a directory with the MD command called Java. Now, I already have that, but if you don't, it'll go ahead and create it for you. I'll change directories to the Java folder, and then I'll make a directory here called poly2. Okay, change directories to the poly2 and notepad poly2.java. Okay, let's go ahead and Control V to paste all this stuff in. Let's save this. All right, excellent. Let's go ahead and scroll all the way up to the top here. You see there's a poly2, and it has the main method entry point here. Okay, now I have actually, now all this basically is, most of this is recycled code from the part 1 there, right? Car, right? And basically Honda Accord extends car, and we're overriding the average price method in there. Toyota Prius extends car, and I've added some stuff in here too as well. Ford Mustang extends car. Shelby GT350 extends Ford Mustang, which extends car. And then also a Tesla S extends car. Don't pay attention to the implements quite yet there. So I added in an interface called tax incentives, right? Because basically a Toyota Prius is like a hybrid, you know, gas electric car, and a Tesla S is a 100% electric car there. So I've added in, so that basically, like, for example, you know, like in real life, you know, you can get government incentives for buying either one of those cars, like tax rebates and stuff like that. So up here I've added an interface called tax incentives, and in here I've got a abstract method called display rate. And just as a refresher, and it's a void return type, so, and it takes no parameters. Just as a refresher, if I were to take this public abstract out, right, it would be the exact same thing. Now, the public abstract isn't implicitly put there, but I always like to explicitly put it there just as a reminder, you know, that this is actually public and abstract, irregardless. Okay? And the only reason I'd really like to do that is just, you know, it's a good habit to get into. Because oftentimes when this isn't here, what you'll find yourself doing on a fairly regular basis, right, is like when you override this, right? Because of course this is an abstract method, so when you implement, we implement tax incentives here, right? We have to override display rate, but you come up here and you'll typically go, oh, okay, bada bing, bada bing, but then you'll get a compiler error because it says, oh, you're narrowing it or whatnot there, because this has to be public, right? And this is because this is implicitly public and abstract. So it's just a good way to remember stuff there on that. Okay. So implementing tax incentives. What do we know about that, right? What do we know about the interface tax incentives? It's very similar to the way we extend car. When we have this average price method in car, we know 100% that every subclass of car, right, will be able to invoke an average price. We know that with 100% certainty. And every subclass and subclass and subclass of car will inherit average price. You can override average price in there, and that's oftentimes what it's great for, you know, and so on and so forth there, right? So Ford Mustang extends car, override average price here with this particular string literal there. Shelby GT350, which is a type of Ford Mustang, extends Ford Mustang, and that overrides, you know, this right with it right there. Okay. But one thing we know is when we implement tax incentives, every single class that implements that is going to have to have, well, basically every concrete class, I should specify, that implements that will have to have a display rebate method inside of it. Okay. So Toyota Prius implements tax incentives. So here's the override for display rebate, displays this string literal to the console. The Toyota Prius qualifies for a $4,000 tax rebate, right? We come down here, Tesla S extends car, implements tax incentives, so we know it has to have a display rebate. If it didn't, it wouldn't even compile, right? And it displays the Tesla S qualifies for a $6,500 tax rebate, okay? All right, so let's build on what we learned in part one up here. Let's make sure this is all saved out here. And I'm going to just, I'm going to compile this. We're going to ignore some stuff here first, and then I'm going to go kind of line by line and rehash on what some of the stuff is doing and introduce some new concepts. So let's compile this, Java, and then let's run it here. Okay, I'm going to scroll up here, and I'm going to bring this down, right down here. Okay, so this is basically what we had in part one there, right? And I did the refresher here back on the website here. A reference variable may be assigned to an object of that specific type or any object that is a subtype of the declared type, right? So in the first one up here, car C1 equals new car, right? So we got a car type C1, and that equals new car. Now it can also be any subtype of it too. So car C2, new Honda Accord, new Toyota Prius, new Ford Mustang, new Shelby GT350, and new Tesla S. And of course, one thing we know is that each one of these particular object types, right, will always have the average price method. So we can go ahead and invoke that average price method off of each one of these. And the polymorphism will basically know which one to actually invoke based on the type of the class. Right? Or not the type of the class, the type of the object, right? The actual object on the memory heap determined at runtime will basically determine which one of these is actually invoked, right? So that's where we get this. You know, the price of a new car, $28,400. Honda Accord, $26,007. Toyota Prius, $23,450. Ford Mustang, $25,800. Shelby GT350 Mustang, $59,400. Tesla S 75,000, right? So even though all these reference variables are of car type, we can refer to objects on the memory heap that are subtypes, right? Subclasses of the car superclass, basically, right? Now let's come down here. And let's take a look at the next thing down here, and that's tax incentives. Tax incentives is our interface here, right? And what do we know about tax incentives? Well, it will force anything that implements it to have a display rebate method. So we also just learned by this statement here, tax incentives, which is an interface. It's not a class, so it's an interface type. And then this is a reference variable, TI1 equals new Toyota Prius. This is a Toyota Prius object. And now we can do that because an interface can be a type for a reference variable, right? And we can basically use the same rule right here. Reference variable may be assigned to an object of that specific type, or any object is a subtype of the declared type, right? And that applies to interfaces as well, right? So we know that the Toyota Prius object will have a display, or the Toyota Prius object on the heap, the instance there, will have a display rate, and so will the Tesla. It'll have a display rate too. So we can go ahead and invoke those, and polymorphism will determine which one that needs to run, basically at runtime there. Okay, so we get the Toyota Prius qualifies for a $4,000 tax rate, and the Tesla S qualifies for a $6,500 tax rebate. Okay, now I'm going to throw a little curveball your way here, because I just really want to drive this point home here. Now, we know that the object class, take for example the car, right? We know this implicitly extends object, okay? Let's see how I want to explain this. Well, let's just go through this here. So I have an object type, right? C array. And what I'm doing with that array is I'm initializing it to all these various different objects, like a new car, right? A new Honda Accord, a new Toyota Prius, a new Ford Mustang, a new Shelby GT350, a new Tesla S. Because basically, you know, every single class will be derived from the object class. It's like the granddaddy of them all. So this is perfectly valid to say something like this, right? And the object class isn't going to know exactly, the object class isn't going to have a clue about the average price method or the display rebate, right? It will have a clue, like for example, the object class has like toString in it and equals and hash code and stuff like that, right? And every one of these will inherit that from the object class, but it doesn't have a clue about average price, right? Because, you know, car, extended object basically, and it has average price, so everything else that extends car will, you know, have that there. We know that much there, right? So I'm using just basically a enhanced for loop, right, to iterate through the C array elements, and I got 1, 2, 3, 4, 5, 6 elements in there, right? And then I'm just basically assigning a reference variable of object type, right? Trust me on this, it might look a little confusing there, right? Now the instance of operator, I don't recommend using the instance operator of a lot, you know, just basically on like rare circumstances. There's some reasons for that there, but for when teaching you how all this works, the instance of operator is a pretty valuable tool there. So the instance of operator can be used to determine if an object is a subtype of another class or interface, right? So you're going, okay, we have object temp. Now what you have to remember is temp is a reference variable. It isn't the actual object that temp points to, right? So in the first iteration, temp actually points to an object that is a car, right? Okay. On the second iteration, temp points to an object that is a Honda Accord. So when we check for temp, is it an instance of car, right? An instance being like, for example, a subclass or of, you know, of car. Is it derived from car, right? Like that Shelby GT350 is a subclass of Ford Mustang, but that's also a subclass of car. So basically, it is an instance of car right there. So this is just the instance of operator will compare an object with another object and say, is this an instance of that? Or in other words, is this right here a superclass of that at some point, right? Like a superclass of a subclass of a subclass and so on down the hierarchy, right? So that's what the instance operator does, and it returns a Boolean true if the object that temp refers to is an instance of the car type. Okay, now, so as we're looping through this object array here, and we're pulling this temp reference variable object type, first iteration is points to a car on the memory heap, okay? So is this temp an instance of car? Well, yeah, car is definitely an instance of car. That's the same thing. We can use now what's called casting. So back to here. We can use a technique called casting to invoke methods from subclasses that are not known to the reference variable superclass type, right? So the reference variable type is object, but object has no idea that there's average price in there. But we can say, okay, we know better than you, right? If I were to just say, for example, like temp dot average price, this is all going to fail out. So this is a syntax for casting here. So we're going to say car type because we know every car, everything that extends car is going to have an average price. So we can cast the temp object here into car type, right? Close it in these parentheses is super critical, and then invoke the average price. Coming down to the next if statement, so if temp is an instance of tax incentives, and tax incentives, remember, is an interface, right? And when we implement tax incentives, guess what? We can check for an instance of that too, right? So temp, remember, is an object reference variable, right? In the first one here, car, no, it's not an instance of tax incentives. That'll return back false, so it doesn't even try to invoke a display rebate message because guess what? Car doesn't have a display rebate message either explicitly defined or implicitly inherited, you know, so that'll return back false. Honda Accord, same thing on the next iteration. Is that object an instance of tax incentives? Oh, Lord, no, it doesn't implement it at all either. How about Toyota Prius? Is Toyota Prius an instance of tax incentives? Oh, yeah, guess what? It is. Because it implements tax incentives, we know that it has a display rebate, has to have a display rebate method inside of it. So we can go ahead and use the syntax to cast it as a tax incentive type for temp, and then invoke the display rebate method. Okay, so let's just go ahead and show you this, how this, what this all comes out to here. I'm going to clear the screen, recompile just to make sure I haven't done any typos screwing around with the code there. Okay, so we've got our right up here, and now the fun begins. And let's scroll up that just a little bit more on that to get all this stuff up there as much as possible there, right? Okay, so on the first iteration through, which this is a car type in this array, right? It displays the average price of a new car is $28,400. Temp instance of tax incentives, now that'll be false, so it won't go down to that. The average price of a new Honda Accord is $26,700, which is the next iteration through. And then we check if it's an instance, well, I'm skipping over this. Temp is an instance of car, right? Because Honda Accord is an instance of car because Honda Accord extends car. Car is the direct superclass of Honda Accord, right? Because we're talking about what the actual object is, right? Not what the instance variable is, okay? But we know we can cast this to type car because Honda Accord extends car, right? Okay, so that's kind of what's going on there, right? So that'll print the average price of a new Honda Accord is $26,700. Now let's check out the next iteration through where we're dealing with this Toyota Prius object, okay? So is the temp reference variable that's pointing to the Toyota Prius object on the memory heap an instance of the car? In other words, is Toyota Prius an instance of the car? Yes, that's true. So let's go ahead and use our car casting to temp and then dot average price, right? So the average price of a new Toyota Prius is $23,450. Come down here. Is the Toyota Prius object the temp is pointing to an instance of tax incentives? Yes, that comes out true. So now we can use the tax incentives casting type to the temp variable and then directly invoke the display rebate, which displays this right here, right? The Toyota Prius qualifies for a $4,000 tax rebate. So you see the first two elements of our C array here did not, display a rebate because they don't have that particular member. Display rebate is not a method inside of either one of those classes. Okay, so Ford Mustang, Shelby GT350, and then finally we get down here to the Tesla S, right? And it displays that instance of car, and then of course the Tesla S, since it implements tax incentive, the test for if temp is an instance of tax incentive comes out true, and then we can go ahead and call the display rebate method there as well, right? And I'm just going to scroll down here and show you, in the Toyota Prius implementing tax incentives, we have to have the display rebate in here. And then same thing in the Tesla S, we have to have the display rebate in here. Okay. All right. The beautiful thing about this whole Object-C array here is it just kind of demonstrates everything about polymorphism. You could put in, for example, like something like integer I, or you could do like, let's do this, like new integer 67, right? Integer, the integer class is a subclass of, for example, like type number, right? But we're not doing any sort of checking or anything like on that there, right? But we're just adding it into this array and showing you here. We can go ahead and compile this. Nothing will be affected. Only the stuff that we're interested in by checking on those instances of things there is what will actually be on there, right? So that doesn't change our output here a single bit. What do we know about everything here, right? We know that all of these inherit a toString object, or the toString method from the object class. What were to happen if we were to just say, we don't even need to check if that, we could just say system.out.println and then temp.toString. We know that the toString method is going to be in each and every one of these. And what I'm going to do is I'm just going to go there, like that. System out println toString plus temp toString, and that'll just print through every iteration there right after the display rebate. Okay. As a matter of fact, what I think I'm going to do is just to make it so it isn't so choppy, I think I'm going to tack on a new line character on the end of that. That'll be much better. And I'll separate it up a little bit there. So let's save this, okay? Let's clear our screen and let's run this. Okay, so now, and the fun begins. So the average price of a new car, $28,000, and basically it's showing us the car object on the memory heap, car at, and then that memory location. And then for the next one, the Honda Accord, right? Honda Accord, object type, and then at memory location there, right? And Toyota Prius, and then the rebate, printing off that there, and then the toString value of, it's a Toyota Prius object at that memory location there. Ford Mustang at that memory location there, right? Now the average price of a new Shelby GT350 Mustang is $59,400. toString equals the 2016 Shelby GT350 has a whopping 526 horsepower. You might be going, what? Where did that come from? Well, from part one, you may or may not recall there, I overrode the average price, or the toString method right here, right? Public string toString. So I overrode that to return back this particular formula instead of the version of toString that is in the object class. So that's where that came from, right? And then here's Tesla. Here is its tax rebate, and here is its value of a Tesla S object at that memory location on the heap. Okay, and then final. Not a lot, there's that 67 integer that came in there, right? And the toString is overridden in the integer class to actually return back whatever the value of this integer object actually is, right? Okay, so I am going to go ahead and close out of this and get rid of that and leave you with some final thoughts here. So At this point, if you are feeling a sense of confusion, that is perfectly normal. Now, my recommendation would be to review the Introduction to Polymorphism, watch it a few times, then wait a day, right? Sometimes your brain just needs time to solidify concept, and a good night's sleep will do just that. The next day, watch the Introduction to Polymorphism again. I always say that word wrong, I don't know, whatever. Introduction to Polymorphism again, and then we will move on to Polymorphism Part 1 and watch it a few times, and then wait another day, right? So watch the one, wait a few times, or watch the first one, Introduction, a few times, then go ahead and watch it the next day once, and then move on to Polymorphism Part 1 and watch it a few times, and then wait another day. Now, just repeat the process, and the concepts will sink in. They will eventually sink in, you know. We all want to learn everything fast, but some concepts just take time. So I always like to say, you know, the more frustration you're feeling, the more you're learning. It's just that simple. So that concludes this tutorial. Thanks for watching.